In this session, we will solve some problems based on pseudo force. So here we have this system. There is a mass of capital M and there is another mass of small m. So small m is a smaller mass and the capital M is a bigger mass, and there is no friction between the mass of capital M and the ground, and the frictional coefficient between these two masses is mu. The question is, what is the minimum force required such that this mass m does not fall down? Okay, so there are two ways of doing this problem. One way is to use the inertial frame of reference. So here we will use inertial frame of reference, suppose. So according to the inertial frame of reference, if I draw the free body diagram of small mass m, it will look like this. There is a normal reaction force towards right, and towards left there is no other force. And suppose it accelerates with a, so we will write it as ma. And now for the case of capital mass, for the small mass m only, for the case of the vertical direction forces, what we will do is that there will be downward force mg and there will be upward force of friction, but that will be mu times r. Okay, the frictional coefficient into r. So mg is equal to mu r. So this is first equation, and we get second equation to be mg is equal to mu r. Now if I take the ratio of both of these equations, then r equal to mg is equal to mu r is equal to mg. Sorry, this is a. This is ma. So this, if I take the ratio, it will be 1 upon mu is equal to a by g. So a is equal to g by mu. Okay. So now we have to find out the force. So force is F equal to m plus m into a. So this will be m plus m into g by mu. So this is the minimum force that will be required to keep the body at keep the mass m in that position, so that it will not fall. Okay, not that position, it will accelerate in the right direction. It will not fall basically. Okay, so now how to solve this same problem with a non-inertial frame of reference. Again, I will draw these two blocks. Now our system is accelerating. Suppose we go and sit above the box m. So if I sit above the block of mass m, this is mass m, and there is a right direction force of normal reaction, and towards left we will have to apply our pseudo force, that is ma. Okay, the pseudo force is in the left direction because the acceleration is towards right. So r is equal to ma according to this. So first equation we got. Okay, and second equation will be same, mu into r is equal to mg. This is mu into r is equal to mg. That is the upward frictional force mu r and downward force mg. So mg is equal to mu r. This is second equation. So if I take the ratio again, then I will get 1 upon mu is equal to a upon g. So a is equal to g upon mu. So I get the acceleration here. And again the force is equal to capital M plus small m into a. So a is equal to g by mu, which we already know. So F is equal to m plus m into g by mu, which is the same answer. So here we went in the frame of reference of small mass m, so which was accelerating frame of reference. So we got the same answer, m plus m into g by mu. Let's look at another sum. Let's say we have a container, and in that container there is a pendulum kept like this. This is the normal position. Now this container is accelerating with the a0 acceleration, as a result of which the pendulum is making some angle theta with the vertical. Now we have to find out what is that angle theta. So the question is, what is the angle theta that it will make with vertical? So how will we do that? So Here, if we draw the free body diagram of mass m, for this mass m, if I draw the free body diagram, what will be the forces? Let me draw it here. The tension force will be in this direction, T. Mg force will be in this downward direction. And the pseudo force will be Ma0 towards left direction. So this time I am taking the pseudo force towards left because the acceleration is towards right. Now, what is this angle? See, this angle is theta. So the tension will make angle theta with respect to this line. Okay. So tension, this is not correct. The tension is, why I drawn tension like this? This is vertical, not tension. This is not tension. This is vertical. The tension is like this, and this is angle theta. So this is angle theta. So T cos theta and T sin theta are the two components. Okay, so let me erase what is this T. This T I will erase. Okay, so now we resolved it into two components, T cos theta and T sin theta. So since this is stationary, so mg is equal to T cos theta. The forces in y direction are 0, the total forces, and in x direction also they are 0. So ma0 is equal to T sin theta. This is suppose 2 and this is 1. If I take the ratio, I will get j by a0 is equal to cos theta by sin theta. So what is a0? A0 is equal to, what is, this is cot theta is equal to, or we will take tan theta. Okay, this is 1 by tan theta is equal to g by a0. So tan theta is equal to a0 by g. So theta is nothing but tan inverse of a0 by g. This is the angle theta that the ball will make with the vertical. Let's look at another one more problem. Suppose we have a wedge, triangular wedge, and there is a mass kept on this triangular wedge, small m. This wedge has mass capital M, and let's say the angle with the horizontal is theta. Okay, and there is a force F in this direction towards right. Now the question is, if all the surfaces are smooth, that means there is no friction between all the surfaces. We have to find out this capital F such that this mass M will not slide down. So how we will do that? Otherwise it will slide down, right? If there is no force F. So how we will do that? Again, same thing. We will say F is equal to M plus M into A. Okay, because this whole mass is moving together with certain acceleration A. Now if we draw the free body diagram of small mass M, what we will see? Mg is downwards. Normal reaction force is like this. And is there any other force? I think so, no. But there is a pseudo force in this direction, left direction, which is Ma. Now these two angles we have to see. So see here, if I see this is R, this is Mg, this is Ma, like this, you can draw it here. So this angle is theta. So what will be this angle? So if I draw it here like this, suppose this is our block and this is direction of R, and these are two components, let's say Rx, Ry. Then this angle is theta, and then according to the alternate angle, this angle will be theta. This will be 90 minus theta. This will be theta. So our Ry component is R sin theta and Rx component is R cos theta. So let's draw that. So let me draw this angle theta like this. So when I resolve this in two components, I will get r cos theta upwards, r sin theta towards right, mg downwards, and this is ma. So what is ma? Ma is r sin theta, and mg is equal to r cos theta. So here if I take the ratio, we will get a by g tan theta. Now what is a? A is g tan theta. G tan theta. So our force was m into m plus m into a. So this will be m plus small m into g tan theta. So this is our force.